The basic idea behind an event dispatcher or delegate in C++ land is that one thing is shouting something to whoever is listening. We'll look at two examples, one for a Blueprint event dispatcher and one for a C++ delegate. In our first example, we have multiple uses of event dispatchers. The idea here is that when a button is pressed, the door should either open or close. When the door state has been changed, the two objects beside the door should let us know what state the door is in. The button has an event dispatcher called button pressed and has no knowledge of anybody listening. It will just shout this to anybody. This is fired when interact is called from the player character. Within BP_door, we're saying at the start, listen for when the button shouts button pressed. When that happens, if we're closed, open us, and if we're open, close us. After that, play the animation to move the door. When the animation is completed, shout to whoever is listening that our state has changed and send along our new state too. There are two separate actors that listen for BP_door and react differently to showcase how one event dispatcher can be used to communicate with many things. BP door report text is an actor that waits for the door to shout, "My state has been updated." From here, it uses the information told at the time to decide whether to set the text to closed or open. The similar but visually distinct BP door report alt listens for the door when the game begins, but also creates a dynamic material so it can change the color when the door shouts about its state. To show the simplicity of what an event dispatcher looks like in C++, it's a delegate, not an event dispatcher, but works in an almost identical fashion. The second example is a simple coin collection minigame. As with the last example, we have an object broadcasting out and then two objects receiving that broadcast and acting accordingly. We've added a seasoning of Blueprint support to allow us to receive the delegate in Blueprint, as the important thing in this sample is the broadcasting of information, not what we do with the information itself, as we've already dealt with that in the previous example. If we take a look at akf_pickup.h, you can see where we have declared the delegate outside of the class and then use that declaration as a variable in our variable list. We mark the uProperty as Blueprint assignable due to the fact that not only does this mean we can use this delegate as an event dispatcher in Blueprint, but we can still communicate in C++ land, giving us the best of both worlds. The other parts of this .h file are giving us a mesh so that we can see the coin, and a sphere component so we can do something when the player overlaps this actor. Just like with the Blueprint assignable flag, we have added Blueprint native event to our overlap function to give us the power of both worlds, allowing us to deal with this overlap either within our .cpp file or in a Blueprint child of this actor. Over in the CPP file, we are setting up the actor, creating our components, and listening out for the overlap. When the overlap happens, we simply broadcast to anybody listening that we've been picked up. The important part of this code we want to look at is this broadcast. Heading back into the project, we have placed the C++ class around the map. We have set the mesh and we've created two classes, one on the Blueprint side to listen out for the broadcast, BP pickup counter, and the other a C++ backed UMG coin widget to showcase how we can communicate with the C++ created delegate in both Blueprint and C++. In the C++ source for UMG coin wallets, you'll notice that the only thing reserved for the delegate in the .h is a U function that's going to fire when we hear what the broadcast has to say. This needs to have the same variables as what's going to be broadcasted, or we won't correctly receive the broadcast. Looking at the CPP, when the widget is created, we cycle through the coins in the world and listen out for their delegate. When their delegate's triggered, we call our coin collected function. This function increases our coin amount and sets the text in the widget to reflect the correct value. There's a lot more to delegates in C++, especially when you forgo the hooks to make them Blueprint compatible. Not every delegate has to be a dynamic multicast delegate. However, for our use case, gameplay, the delegates we've used today are a great introduction to get started with delegates as a whole. From here, you should be able to imagine some of the places you can apply this knowledge, such as replacing tick functions when you're checking values and changing of values to a more delegated approach. To create a Blueprint event dispatcher, open the Blueprint in question and head to the My Blueprint tab, which usually is in the bottom left. There's a section called Event Dispatchers. Click the plus icon on the section header and create an event dispatcher. Name your event dispatcher, and then if you need to add a variable to it, click the dispatcher and head over to the details panel, which is normally on the right. Click the plus on the input section to create a new variable. Set it, name it, compile and save, and your event dispatcher is ready. To learn more about delegates, take a look at the Unreal Engine documentation to learn about cool extra things, such as adding return values and the uDelegate macro.